Hello, welcome back to another AP3 video. In today's video, we're going over AP Environmental Science, topic 7.2, Photochemical Smog. So we're going to do a little review on how we get primary pollutants, which we went over in 7.1. So we get a fossil fuel and we're going to do combustion, and those pollutants are just goes into the air naturally. So it's just pollutants going into air naturally. They're secondary, but I'll elaborate that a little bit more in this video. So some examples of primary pollutants are NOx, or nitrogen oxides, and volatile organic hydrocarbons, or VOCs. We're going to call it VOCs because it's better to do the abbreviation than like the huge wording, because they use VOCs. They more than likely will use the abbreviation than the actual the full name of it, basically. So again, to get primary pollutants, the pollutants from a fossil fuel during combustion, and that's about it. And it just goes into the atmosphere. So what are VOCs? Well, they're named volatile because they can be vaporized at room temperature. They're considered of hydrogen and carbon, and its increased presence in the atmosphere. Some examples, it could be anthropogenic, or it could be natural resources such as trees and many plant oils. And lots of essential oils contain VOCs. So now we're going to talk about, it's going to be the formation of smog. So I kind of drew this in the previous video, but again, the pollutants are could be from cars, or it could be from natural, like from a volcano. But basically from a volcano, the pollutants like NO or NO2 release into the atmosphere, and then after it can either go with sunlight, or it could go with heat in order to make different chemical compounds, which is secondary pollutants. Basically, it combines with either water vapor or sunlight to make a different chemical. So instead of NO2 or NO and NO2, we're gonna get O3 and PANS. So when it comes to the sources, I didn't go over what I wrote. So the sources are gonna be in urban areas with many cars, and then after the pollutants, it's gonna become a primary pollutant as it rises up into the atmosphere, making nitrogen oxides and VOCs. And then the transport conditions, so it could be heat and could be heat, making the secondary pollutants, making a new chemical. So it could be ozone and PANS, like we talked about right now. So we're going to talk about a little bit the chemistry of photochemical smog. So what I have in red are going to be primary pollutants. What's in green is secondary pollutants, and what's in orange or yellow is the environmental factors. Basically, what we need to know is going to be that NO and VOCs combined with O2 and UV makes O3 and PANS. That's what we basically need to know. And I wrote the chemical formula, like the process, but what's in the bottom is like basically the summary of the whole thing, which is the most important part. So now we're going to talk about the factors influencing photochemical smog. Timing. Nitrogen oxides produce early in the day, and it happens morning rush hour, and stays around when sunlight and the temperature starts to increase. And ozone concentrations peak in the afternoon, and it happens when there's an increase in sun intensity and temperatures. And then there's also location seasonality. Ozone levels are higher in sunny, warm climates, and ozone levels are higher in sunny, warm climates, and ozone layers are also higher in the summer. The more southern, the more photochemical smog. So now we're going to talk about the human impact helps. So when it comes to photochemical smog, it irritates the eyes and throat, can worsen existing heart and lung conditions, and regular long-term exposure can cause lung cancer. So tropospheric ozone, it affects on humans, can worsen many things, can trigger asthma, and causes permanent damage to lung tissue. Additional impacts of tropospheric ozone can be on plants, and enters plants through the stomata and burns plants tissue, leading to leaf damage and reduced survival. So what can we do to reduce photochemical smog? Well, let me zoom out a little bit so you can see all the information. So what we can do is we can reduce nitrogen oxides using catalytic converters. It converts NO into O2 and N2, and CO carbons react to produce CO2 and H2O. Enforce emissions testing and standards for vehicles, and increased production of CO2 can reduce nitrogen oxides. To reduce VOCs, they're primarily from gasoline, so we can pump up gas at night. And another thing is that we can follow gasoline refueling instructions for efficient vapor recovery, but be careful not to spill fuel, and always tighten your gas cap securely. So we're going to talk about other tips to reduce smog and its effects. So we can improve your fuel efficiently, we can keep engines properly turned, and make sure tires are properly inflated. And we can reduce the use of internal combustion, so make fewer trips, bike or walk. We can either use public transportation or carpool, and avoid idling your engine, and we can reduce human impacts, minimize outdoor activities in the late afternoons in summer, and wear a mask. That's everything we need to know for 7.2. This is another AP3 video. Thank you for watching.